Now my dear students, we can go to the question number 34. CH3, CH2, CHCl, CH3 obtained by chlorination of normal butane will be which of the compound, that is chlorination of normal butane, and you can get this compound, my dear students, and this compound is mesoform or racemic mixture or this D form or L form. Here my dear students, you can get only one carbon atom. Concept is this, concept of this question, only one carbon atom asymmetric, only one carbon atom asymmetric is present, only one carbon atom asymmetric is present, so it is not mesoform, so it is not mesoform, because my dear student, in mesoform 2 carbon atom must be there for mesoform 2 asymmetric carbon atom, 2 asymmetric carbon atom must be there, must be present. So my dear students, it's not a mesoform and it is not a only D form, because here when normal butane reacts with or hydrolyze this chlorine, it's a free radical mechanism. So in free radical, this chlorine attached with this another free radical, in it's a two different side, so it may cause the D form as well as L form. So my dear students, its answer is that racemic mixture, because in racemic mixture, 50% of D form and my dear students 50% of L form is present. When you form this racemic mixture, you can get the 50% of D form and 50% of L form you can get. So my dear students, it's a racemic mixture. Now we can go to the question number 35. Here my dear students, an organic compound AC4H9Cl, then you must take the reaction. A compound in which molecular formula is C4H9Cl reacts with this compound, sodium and diethyl ether. Sodium and diethyl ether gives hydrocarbon. You can contain hydrocarbon, and after monochlorination of this hydrocarbon, only one chloro derivative is present. It means this sodium and ether, my dear students, this reaction is a name reaction and it is called Wood's reaction. Now you think about this Wood's reaction. Here my dear students, what is the concept? You think about this Wood's reaction. In Wood's reaction, my dear students, RCl, when reacts with this sodium in ether, another molecule of this RCl, both are reacts with each other, and in this way twice NaCl. You get the twice NaCl is removed, and my dear students, you can get this alkanes. So my dear students, when you prepare these alkanes, means it's a hydrocarbon by C4H9Cl. Here C4H9Cl, you can prepare hydrocarbon, means this alkyl radical is a C4H9. You can get here C4H9 It may be a normal, it may be a iso, it may be a tertiary. But here this, it may be normal iso or tertiary. Here he get hint for you, only one chloro derivative is formed. Only one chloro derivative is formed. My dear students, when only one chloro derivative is formed, it means all the primary carbon atoms are present in the hydrocarbon. It means, my dear students, all the alkyl groups are have primary carbon atom. No secondary or tertiary carbon atoms are not present in hydrocarbon, because question is that in question one chloro derivative is present. If two carbon atom, primary, secondary, two carbon atoms are present, it means you can get two chloro derivative. If three different carbon, primary, secondary, tertiary, if you get primary, secondary, tertiary carbon atom in alkyl group, it means here you can get three chloro derivative. This is the concept, my dear students. So, my dear students, when this alkyl group is CH3 here, you can write here primary carbon atom. So, you can write here primary carbon atom CH3 and you can write CH3 1, 2, 3, 4, because here 4 carbon atom alkyl group is present. Then you can write here 1, 2, 3, 4 Cl plus another molecule of twice Na plus, that is Cl, CCH3, CH3 and CH3. And now, my dear students, you can replace this twice NaCl. This is the twice NaCl, you can replace this twice NaCl, and when this twice NaCl is replaced and two this group is formed, and you can get the two groups is formed, and that is the, you have and my dear students, you have the this compound which gives only primary alkyl or primary chloro derivatives. Here, my dear students, when you can replace this hydrogen, CH2Cl is formed. Here replace hydrogen, CH2Cl is formed. Here you can 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 replace hydrogen, CH2Cl is formed. It means all these compounds only form one chloro derivatives compounds. So, my dear students, answer is your, this is called tertiary alkyl group. So, 1, 2, 3, 4. So, it is called tertiary butyl chloride, and this is your answer, tertiary butyl chloride. You can go the answer C. 35, you can go the answer A. In 35, you can go the answer A. Now, my dear students, we can see the question number 36. A compound of molecular formula C7H16 show optical isomerism compound will be. Now, you can see here molecular formula C7H16. Simultaneously, you can see the options. 2,3-dimethyl pentane means all options are the here, all options are the, that is aliphatic compound. So, first option you can make the structure A, 2,3-dimethyl pentane. First of parent hydrocarbon is 5, 1, 2, 3, 4 and 5. Here, my dear students, second and third, here CH3 and CH3, you can put here CH3 and CH3. That is why you can get here two 3-dimethyl pentane. Now, my dear students, in 2,3-dimethyl pentane, 1, 2, 3, 4 and 5. Optical isomerism is shown by those compounds in which chiral atoms are present. Concept, we can see this chiral carbon atom in the molecule. We can see, my dear students, chiral carbon atom in the molecule. So you can see here which chiral carbon atom is present here. Here no chiral carbon atom is present, because chiral carbon atom in which 4 different groups are attached with single carbon atom. Here you can see here 4 different groups are attached with a single carbon atom. Here you can see this carbon atom, same groups are present here, and 1, 2, 3 dimethyl pentane. When we see this carbon atom, okay, you can see this carbon atom, this is here methyl group is present, here this is methyl group is present, same group is present, so this is not a chiral carbon atom. Here you can see this methyl hydrogen is present here, and in this form this is not a chiral carbon atom. This is not a chiral carbon atom, but this compound you can see here 1, this is 2, this whole molecule is this 3, here this whole molecule is 4. Then, my dear students, this is chiral carbon atom here present, because here you can see this carbon atom, third carbon atom, 1, 2, 3, 4. 4 are different groups are present. So, my dear students, say chiral carbon atom, and chiral carbon atom is present means that molecule show optical isomerism. So, my dear students, you can go the option A. First of all, you draw the structure, and when you draw the structure, and you can find out that carbon atom in which 4 different groups are attached. When 4 different groups are attached, that carbon atom is called chiral carbon atom. Now, my dear students, we can go the 37 question. Which of the following compounds is not chiral? Not chiral. A option, you can see here, this is the chiral carbon atom, because here this group, 4 groups are different. Here you can see this group, this is the chiral, 1, 2, 3, 4 group is different. Here you can see D, this is 1, 2, 3, 4 are different. Here CS3 and here CS2D, different groups are present. So, these are chiral. Here, my dear students, answer is C. Here chiral carbon atom is not present, because here 2 groups are same, hydrogen with carbon, here 2 hydrogen is same with carbon, here 2 hydrogen is same with carbon. So, my dear students, answer is C, 37C. This question is asked in your NEET exam 1998. Now, my dear students, when we go to question number 38, replacement of chlorine of chlorobenzene to give phenol requires drastic conditions, but chlorine of 2,4-dinitrochlorobenzene is readily replaced because. Here, my dear students, you see the concept. First of all, you see 2 compounds here. He says about 2 compounds. Number 1 compound is here. This is, my dear students, chlorobenzene. Here this chlorobenzene is the first compound, my dear students, and here second compound is this is known as NO2 group, and this is known as NO2 group. When you write the numbering 1, 2, 3, 4, then it is called 2,4-dinitro chlorobenzene. Here, my dear students, you can see here in this question 2 groups you have, and question is that here this replacement of this chlorine in chlorobenzene is easy. This replacement of chlorine in chlorobenzene is not easy. It is replacement of chlorobenzene is only occur at drastic condition, means high temperature and high pressure. But when you can remove this chlorine in this 2,4-dinitrobenzene, it is easy with compared to this chlorine. Why? My dear students, you can I can tell you in this paper, in these questions already discussed that NO2 group is a E electron withdrawing group, and this is also called, my dear students, electron withdrawing group. This electron withdrawing group, my dear students, accept the negative charge or electrons from which are present in ortho and para position. So, my dear students, negative charge or electrons are not go to the chlorine atom. So, this is withdraw due to the withdrawal of NO2 group. My dear students, chlorine is easily replaceable, or you can say that 2,4-2,4-dinitrobenzene is readily replaced. So, my dear students, answer is B. B is the correct answer of this question. And this question is asked in 1997 NEET exams. Now, my dear students, we can see the question number 39. The alkyl halide is converted to an alcohol. My dear students, it is a very simple question, very simple reaction, and you can easily understood answer. Alkyl halide means Rx when reacts with this KOH, and my dear students, its KOH is the alcoholic, this KOH is a aqueous KOH. This KOH is a aqueous KOH, means KOH is dissolved in water, then this R minus is replaced by this K plus, and you can get this ROH, and this ROH is alcohol and KX is replaced by this alcohol. So, my dear students, here you can get the alcohol by this reaction, and this reaction is called substitution reaction. It is also called, when alkyl group is primary, then it is called SN2 reaction, and this is a tertiary for primary alkyl halides. For primary alkyl halides, it is called SN2, and for when it is called SN1 for when tertiary alkyl halide. Tertiary alkyl halide. But problem is that, my dear students, when you can get the secondary alkyl halide, it show SN1 and SN2 for secondary alkyl halide. So, my dear students, it is depends upon secondary alkyl halide. When secondary alkyl halide, you can get the secondary alkyl halide, it gives SN1 as well SN2. It depends upon the bases, which bases you can use. When you can use this type of base which easily replace the halide ions and carbocation is formed, then you can go the SN1. When weak base is present and not replace this halide ion, then SN2 transition states are formed. So, my dear student, this is also a concept, and you must be learn, my dear students, concept of these reactions SN1 and SN2, which are always you see in your question paper. This is the concept, my dear students. This is the question number 40. When we see this question number 40 here you can see this the base or nucleophile, base as well as this is nucleophile, and this nucleophile is attack on this carbon atom and removal of Br minus ions. You can see here CH3 H here, CH2 CH3 5, OH ions are here present. That is why, my dear students, you can see here this is the type of SN2 type 40 question. OH ions is present here and this inversion is occur. Here you can see the inversion is occur, but carbocation is not formed. Because carbocation is not formed, so my dear students, this is the type of SN2 reaction. Because my dear students, carbocations are not formed in SN2, only transition states are formed. So, we can go to that is option A. This question is also asked in NEET 1997, my dear students, when we see the question number 41. Here you can see the reaction of tertiary butyl bromide with sodium methoxide produces. My dear students, you can see the reaction, and in this reaction, my dear students, tertiary butyl bromide, you can write this formula, tertiary butyl bromide. This is the tertiary carbon atom. Here this is the Br group. Tertiary butyl bromide reacts with sodium methoxide, CH3ONa. It is called, my dear students, sodium methoxide. To produce. My dear students, it is a strong base, and when this strong base is attack on this compound, here you can see that this strong base, work of strong base concept is this nucleophile, strong base and nucleophile. Nucleophile CH3ONa or C2H5ONa act as CH3ONa or C2H5ONa act as strong base also. So, my dear students, here this CH3ONa, when attack this compound, you can see here this attack this compound here, CH3 group, stirring the CH3ONa. CH3ONa is searching the carbocations which are present inside this group. So, my dear students, CH3ONa is also act as a nucleophile. When this bromide ion is present in the solution, then CH3O minus is not such this carbocation, then it replaces the H plus ions from the methyl group. And my dear students, it is formed methanol. When it is formed methanol, my dear students, then this compound CH3 double bond CH2 is formed. And my dear students, this is called isobutylene. 1, 2, 3, 4 carbon atoms are present, that is why it is called isobutylene, because double bond is present. This is not a isobutane, here double bond is present, that is why it is called isobutylene. So, my dear students, answer is D. Your answer is D. You must be go the answer D. Now, we can discuss the question number 22. Here, my dear students, Grignard agent is prepared by the reaction between. You always know preparation of Grignard agent what is. When, my dear students, alkyl halide Rx reacts with magnesium in presence of ether, Grignard agent is formed because this magnesium reacts with this halogen, it is form a RMGX and it is the Grignard agent. Grignard get the Nobel Prize for the formation of this reagent, my dear students, and because this Grignard agent we can produce all the compounds which are given in your, all the aliphatic compounds which are given in your organic chemistry. For example, alkane, aldehyde, alcohol, carboxylic acid, amines, ether, all compound acids, all compound acid derivative, you get all the compounds by this reagent. So, my dear students, did not get the Nobel Prize for the preparation of this reagent. Here this Rx alkyl halide, when this alkyl halide, here you can see the alkyl halide is positively charged and this halogen is negatively charged. But when this magnesium is reacts with ether and form the complex, and when this complex is broken, then this alkyl group get the negative charge and magnesium get the positive charge. So, my dear students, you can go the answer D. Question number 42, you can get the answer D. Now, we can see the question number 43. Here, my dear students, chlorobenzene reacts with magnesium in dry ether to give a compound A, which further reacts with ethanol to yield. Yes, we can make the reaction. Here, my dear students, chlorobenzene, you can write the chlorobenzene. Here, this is the chlorobenzene. This chlorobenzene reacts with magnesium in presence of ether. My dear students, then you can get the Grignard agent. And what is the Grignard agent, my dear students? Grignard agent is the C6H5MgCl. This is the Grignard agent. You can also write in this way, this is C6H5 MgCl. Now, my dear student, this is the first action. Now, here we can take this Grignard agent or this is a compound A. When this compound A means C6H5 MgCl is hydrolyzed by water or ethanol, it is ethanol. To give which compounds? My dear students, when this ethanol reacts with this compound, it gives us H plus ions. You get H plus ions from this compound and C2H5O minus ions. Here, my dear students, when you can broken this, you can get the positive charge and negative charge. Here, my dear students, this H plus ions attached to this negative charge and this negative ions attached to this positive charge. Now, my dear students, you can get the C6H6 plus MgOC2H5 and this Cl. This is called, my dear students, benzene. So, your answer is 43, your answer is benzene. Now, we can see the question number 44. Benzene reacts with N-propyl chloride in the presence of anhydrous AlCl3 to give. Here, my dear students, this is the reaction. This is the benzene and this is CH3, CH2, CH2Cl. This compound is called N-propyl chloride. This N-propyl chloride reacts with anhydrous AlCl3. My dear students, if you broken this compound minus charge and plus charge, here AlCl3 accept this anion, AlCl3 accept this anion and form its AlCl4 complex, because this AlCl3 is a Lewis acid. This AlCl3 is a Lewis acid. So, this AlCl3 reacts with this chloride ions to form AlCl4 minus ions. Now my dear students, this cation is attached in this carbon atom or not? Here my dear students, you can see here, this is the primary carbocation. If primary carbocation is present in the rings or in the reaction, it may be converted or rearranged. It may be rearrangement is maybe occur. Rearrangement, it may be occur my dear students, then this carbocation is rearranged. Here my dear students, this carbocation is rearranged, this hydrogen atom go to this carbocation and this positive charge develop on this carbon atom. Then my dear students, you can get the second carbocation, it is called, after rearrangement of this carbocation you can get the secondary carbocation. And you know very well, this secondary carbocation is more stable than this primary carbocation. So, it is occur, and you can see here this CH, CH3 and CH3 is formed. It is called isopropyl group. Isopropyl benzene is formed. So, my dear students, your answer is D. This is isopropyl benzene. First of all, this carbocation is rearrangement, and after rearrange this carbocation, this compound is formed and it is called isopropyl benzene. Now, my dear students, we can go to the question number 45. Here, my dear students, which chloro-derivative of benzene among the following would undergo hydrolysis most readily with aqueous sodium hydroxide to furnish the corresponding hydroxy derivative? My dear students, these are all benzene chloro-derivative or chlorobenzene. Here you can see in chlorobenzene, if NO2 group is electron withdrawing group, my dear students, these are the electron withdrawing group, and this electron withdrawing group, what happened? This electron withdrawing group, my dear students, increase the reactivity of this benzene ring, and this Cl minus ions easily go to the solution. And when this sodium hydroxide, this reacts with this sodium hydroxide NaOH, then OH minus ions attach with this carbon atom and you get phenol. So, my dear students, in this hydrolysis, when this chloride ions is removed by when more number of each electron withdrawing group are attached. Here these are the electron withdrawing group. So, my dear students, answer is your question number 45. Your answer is, my dear students, A. Now, my dear students, I am complete this chapter. All concept you learn and you remember. I give you all the concept which are useful or which are this concept is obey the reactions. Thank you very much.